Hi students, welcome to the session. I am Dr. K. Varada Rajkumar, Associate Professor, Department of CSC, AIML, MLR Institute of Technology, Hyderabad. In our previous 3 classes, we learned about what is graph and how to represent graph and graph editing. In this class, we will see an important topic regarding graphs is graph traversal. We can traversal graph in 2 ways. One is DFS, another one is BFS. So DFS means depth first search. So BFS means breadth first search. In this session, we concentrate on DFS. So depth first search. Overview of the presentation. In this presentation, we see what is graph traversal and we see depth first search and applications of traversing, and we see DFS algorithm, and finally we discuss DFS algorithm with an example. Outcome of this lecture: at the end of this lecture, you all are understand DFS algorithm and its purpose. So what is graph traversal? So graph traversal is the process of visiting all the nodes in a graph systematically. It is an essential operation in many algorithms and applications related to graph theory. The main goal of graph traversal is to explore the vertices and edges of a graph to understand its structure or to solve problems related to the graph. The 2 most common ways a graph can be traversed are depth first search and breadth first search. So simply saying, so graph traversing means visiting all the nodes present in the graph. So for this we use 2 most common ways. One is BFS and another one is DFS. In this session, we see how DFS algorithm works. So DFS, depth first search. Depth first search is a fundamental graph traversal algorithm used to explore all nodes and edges of a graph. Depth first search is said to go deep. Here we are using depth. So why depth means? Here we are going to go deep because it visits a vertex, then an adjacent vertex, and then the vertex, adjacent vertex, and so on. That means, for example, this is the graph A, B, C, D, E, F. Now, so what is the depth here? The depth node is F here. If you start from A, you move to last node, deep. So why? Here A to B, B to D, D to F here. Now, so DFS, depth first search, is set to go deep. So because it visits a vertex. For example, if I visit A, then a adjacent vertex from A to B, the adjacent vertex is B. So A to B I traverse. Then again you traverse from B to D. So D is the adjacent vertex to B here. Again from D to F. Now F is the adjacent vertex to D, so you visit F here. If you observe, this is the deep here from A to F. After that we visit C here. Okay, that's why. So this algorithm we call as a depth first search. In this DFS we use stack. DFS can be implemented using stack. Traversing algorithms, DFS and BFS, we use it to find path. So DFS can be used to find path between 2 nodes, and we use these algorithms to find is the graph contains any cycles. Cycle detection. In an undirected graph, DFS can help in detecting cycles. And topological sorting. For directed acyclic graph, DFS is used to perform topological sorting. So connected components. So DFS helps in finding all nodes connected to a given node. So these are the some of the applications of DFS. So let us see the DFS algorithm. Here in DFS algorithm, we use stack. So step 1, initialize the stack. So create an empty stack and initialize a set to keep track of visited vertices. Next, choose one starting vertex. Select any vertex to start the traversal and push this vertex onto the stack. Now explore adjacent vertices. Pop a vertex from a stack. If it has not been visited, mark it as a visited and push its unvisited adjacent vertices onto the stack. Repeat this. Continue this process of popping a vertex from the stack, visiting it and pushing its unvisited adjacent vertices until stack is empty. This is the condition. Until stack is empty, visit the vertex and the adjacent vertices are pushed into the stack and again pop until stack is empty. So let us discuss with one example. You remember these points, 4 points: initializing the stack and choosing the starting vertex and exploring the adjacent vertices. Okay. So consider this graph. Okay, so it is the step 1, initialize stack. I consider this as a stack and take one array to store all the visited vertices. So let us assume, so this is the array. Okay, so now initially these two are empty. What is the step 2? Select any vertex from graph to select as starting vertex. Now in this case I select A here. So step 1, push the selected vertex into stack. So this is the A. Okay. Now what is the second step? Pop the vertex from the stack. So pop. So here I am drawing. So A is popped and make this A as a visited and A adjacent. So what is the adjacent here? For A, B, C. Insert C, B. Insert adjacent vertices into stack. Now again pop. If I pop, what is the element I am going to pop? B here. So B adjacent. So B adjacent are D, E here. So make this B as a visited and push these values into stack again. So C, E, D. That's it. Again pop D. So now this is the D. Now what is the adjacent vertices of D? H. Now D is visited and this H is pushed into the stack. So it becomes as C, E, H. Next again pop. So H. H adjacent D, E, F, G. D already visited. So ignore. Remaining E, F, G pushed into the stack. So it becomes as, and make this H as a visited. C, E, G, F, E here. Next pop E. E adjacent vertices are B, H. Both are visited. So this is the resultant stack C, E, G, F. Okay. Now again pop F. F adjacent vertices are H, C. H already visited. So again C, E, G and C here, and make this E and F are visited. Okay, now pop C. So C is visited. C adjacent are F. F is already visited. A is already visited. Again G. So it become as C, E, G, G. Now again pop G. G adjacent vertices are H. H is visited. F. F is visited. C. C is visited. No need to push any adjacent vertices. So G is deleted and G is visited. Now again G, same happened. No vertex is inserted into the stack, and E already visited, C already visited. So the stack is empty. If you pop all the elements from the stack, stack is empty now. Now this is the traversing A, B, D, H, E, F, C, G. If you observe here, you start from A and you traverse to depth first. A, B, D, H. Then we visit E. From E to F, F to C, C to G here. That's it. Now this traversing we call as depth first search. So coming to summary of the session. In this session we'll learn DFS algorithm. So DFS explores nodes by going as deep as possible along each branch before backtracking. It uses stack, or sometimes we use recursion also, to manage traversal. The algorithm involves initializing a stack with starting vertex and then repeatedly popping vertices from the stack and processing them and pushing their unvisited neighbors until the stack is empty. I hope you all are understand DFS algorithm. If you have any doubts, place your doubts in the comment section. I will answer all your doubts. So thank you.